Hey, welcome. We're going to be talking about factoring today. And below are your hints in factoring. You want to take out your greatest common factor first. No matter what the problem, you always look for a greatest common factor. Now, the second hint works if there's two terms. That's if it's one of the specials like differences of squares, sum of cubes, or differences of cubes. If there's three terms after you take out your greatest common factor, you want to try your AC factoring. In other words, A is what's in front of your squared term, C is the one that has no variables. You multiply them together and find two things that multiply together to give you what A and C give you that happen to add up to give you the value of B. And we'll go through some problems like that. If there's four terms, then you factor by grouping. So here we do our first step. Once again, our first step is always greatest common factor. So we look to see what goes into all these. So if you look at the numbers in front, you should realize there's a 5 that goes into all of them. Also, there's A's in all of these. The smallest exponent is an A to the first, so we could take an A to the first out, and then you'll notice they all have B's, and the smallest exponent on your B's is a 1, so we can take a 5a and b out. And then you got to ask yourself, 5ab times what gives you this first term? Well, that would be a 2a squared b. And then you got to ask yourself, 5ab times what gives you the second term? Well, that would be a 3a. And then you got to ask yourself, 5ab times what gives me 5ab squared at the very end? And that's just a b squared. Sometimes after you take out your greatest common factor, what's left in the parentheses will factor farther yet. In this case, it doesn't. Looking at the top right problem, the first thing you want to do is to look for a greatest common factor. And there isn't one that is helpful. Your greatest common factor here is 1. And pulling out a 1 doesn't change your problem, doesn't help us. So there you'll notice there's four terms, so you look for factoring by grouping. With factoring by grouping, you look at the first two and say, oh, what could I pull out of the first two? And well, you realize that that's an x squared. Then you got to think, okay, x squared times what is x cubed? And that's an x. X squared times what is a 5x squared? And well, that's a 5. And then you look to see what you can pull out of the last two. Well, we could pull out a negative 2, so I'll put a negative 2 in front. And then you got to think negative 2 times what is negative 2x, well, that's an x. And then a negative 2 times what is negative 10, and well, that's a positive 5. Now, factoring by grouping, you're on the right track if both parentheses end up being the same, which they are. So if we rewrite this, you'll notice that we have the same thing showing up here in parentheses in the green. Now, side note, let's go down here and do this. You guys know if you had an x squared times a minus a 2 times a, you could factor out that a. So what your x squared and your minus 2 are being multiplied by is like your greatest common factor. Here we have x squared times triangle minus 2 times triangle, so you could pull out that triangle. That's the same thing we have up here. We have an x squared times mumbo jumbo minus 2 times that same mumbo jumbo. So we could go ahead and pull out that mumbo jumbo. That's our common factor. Well, what's left? Well, we're going to be left with this x squared, and we're going to be left with this minus 2 in our other sets of parentheses. So that's factoring by grouping. So why don't you pause the video, see if you can do these two quickly. So on this first one, you look for your greatest common factor. You're going to go ahead and pull out an x and a y squared. Then you got to look at what xy squared times what gives you that first term. That's a 6x cubed. Xy squared times what gives you the middle term, and that's a 9x. Xy squared in front times what gives you that last term, and well, that's just a plus 1. Here, there's no greatest common factor that's going to be helpful other than 1, which doesn't help us. So we factor by grouping because there's four terms. We look to see what we can pull out of the first two, which is an x squared. We pull an x squared out. And then in parentheses, that leaves us with an x and a minus 3. looking at what we can pull out of the last two, which would be a positive 4. And I encourage you to actually write plus 4 because it's going to help you see what's left over afterwards. If you pull out a positive 4, you'll realize you're left with an x minus 3. You'll notice both sets of parentheses are the same, which is good. So what we have here in green of an x minus 3, that's like your common factor. You pull that out. Now that that common factor is pulled out, you're left with just this x squared, and you're left with a plus 4. So here we're going to do our first step, which is always greatest common factor. You'll notice you could pull out a 3 and an x. So we pull a 3 and an x out, and then you got to think 3x times what is this here, which is an x squared. 3x times what is your negative 12x, and well, that's just a minus 4. So before we continue, we need to cover our specials. Differences of squares factors into two identical parentheses, one's positive and one's negative. What goes in the beginning of each parenthesis is you got to think about what was being squared to give you that first term. What goes in the end of each parenthesis, you got to look at the end and think, okay, what's being squared to give me that end? Something similar down here with differences of cubes and sum of cubes. The differences of cubes and sum of cubes formulas are here. Whatever was being cubed, not the final answer, but what you're cubing here, that's what you put in for this box, and this box. At the very end, whatever's being cubed to give you that last answer is what you put in for this triangle, and this triangle. Notice with sum of cubes and difference of cubes, this formula or a sign here matches this. This sign here matches this. The second sign we come across is always opposite that first sign. And then the last term is always positive. So as we go up here, you'll notice we have only two terms left in the parentheses. It's an x squared minus 4, which is really a differences of squares because 4 is really a 2 squared. So it's going to factor into two identical parentheses like this. One of them is going to have a plus, one of them is going to have a minus. Doesn't make a difference which one you do. Then you got to ask yourself, what's being squared here? Well, it's an x that's being squared. That's what goes in the beginning of each parenthesis. And then you got to ask yourself what's in the end that's being squared. It's a 2 that's being squared to give us that 4. That's what goes in the end of each parenthesis. So put an x in the beginning of each parenthesis, a 2 in the end of each parenthesis. One of them has to be plus, one of them has to be minus. Now in the top right problem, you look for your greatest common factor. There is none, but you notice we have two terms. So you want to see if it's one of the specials. We have a plus sign. Only one of the specials has a plus sign, and that's sum of cubes. So we want to see, is this something cubed? Well, the first thing is obviously something cubed. It's really an xy all cubed. And then you got to think, is 8 something cubed? Well, it's really a 2 cubed. So then you got to think, okay, my box down here corresponds to what's being cubed, which is xy. So each one of these boxes here gets replaced with an xy. My triangle down here is what's being cubed at the end. Well, here at the end, I have a blue 2 that's being cubed. So each one of these triangles here gets replaced with a 2. So if I do that, I end up replacing all my boxes with an xy. I get this. Replacing all my triangles, my formula, with that 2, I would get this. And then we're going to go ahead and do a little bit of simplifying. There's nothing we can do in the first set of parentheses. I'm going to actually square my x and my y. And it's common practice to put your coefficient of 2 in front of your variables. And we're going to go ahead and square our 2 and just write 4. Now, these differences of squares, differences of cubes, and sum of cubes formulas, I will not give you on your test or your quiz. You will need to have those memorized. So here we have two terms, no greatest common factor. Is it differences of squares or differences of cubes? Well, we have a squared here, so I'm going to think this, and we also know that 9 is a 3 squared, so you got to think, okay, each box, your box is what's being squared, which is my x. My triangle is what's being squared at the end, which is my 3. So I replace each box with an x, and I replace each triangle with a 3. Very similar down here, we have two terms that are being added, and we actually have two things added that are both cubed. That's semi-cubes down here. So then you got to think each box gets replaced with what's being cubed in the beginning, which is it's an x being cubed, so each box gets replaced with an x. And then your triangle is what's being cubed at the end, which is a 3, so each triangle here gets replaced with a 3. And then we could do a little bit of simplifying, nothing in the first parenthesis, put the 3 in front of our x, and then square our 3 at the end, and we get 9. Now we're going to go ahead and do our AC factoring. There's no greatest common factor here other than 1, and that's not helpful. Our A is the 2, our C is what's at the end of negative 3. We multiply those two together, and we get negative 6. Now I'm going to go ahead and list the factors of negative 6. I could have a negative 1 and positive 6. I could have a negative 6 and positive 1. I could have a negative 3 and a positive 2, or I could have a negative 2 and a positive 3. I want to choose the pair of factors that adds together to give me a positive 1, and that's the orange one that I have here. So I'm going to rewrite this. My 2x squared, instead of writing x, I'm going to write a negative 2x and a 3x. Now negative 2x and 3x is the same thing as a positive x, so we're not changing the problem. And then we still have to have our minus 3 at the end. So now we just do our factoring by grouping. Out of the first two, you can pull out a 2x, and you're left with, in parentheses, an x minus 1. Out of the last two, you can pull out a positive 3, and then you're left with an x minus 1. You'll notice the parentheses are the same, so that's like your common factor. You can pull that out, and then you look at what's left, which is your black 2x and your plus 3. That's your AC factoring. So in this problem over here, we find our A, we find our C, we multiply them together, it gives us negative 15. We write out all the different possible combinations of numbers that multiply together to give us negative 15. And that's all these. Then we want to look at the pair of factors that will add together to give us this negative 2, which is what I have highlighted in orange. So I'm going to go my 3y squared. Instead of writing negative 2y, I'm going to replace negative 2y with a negative 5y plus 3y. And you should know that negative 5y plus 3y is really that negative 2y. And then bring down my minus 5, and we do our factoring by grouping. Out of the first two, we can pull a y, and then we're left with a 3y minus 5. Out of the last two, there's really nothing to pull out. It's really pulling out a plus 1. So now you notice both sets of parentheses are the same. So we can go ahead and pull out that green, and then we're left with the black. That's your AC factoring. So go ahead and factor this one quickly. This one here is differences of cubes. So we'll go ahead and work this out. What's being cubed in the beginning is AB, so don't get stung. It's AB. And then we replace each one of our boxes with AB. What's being cubed at the end is a 3, so we replace each one of your triangles in your formulas with a 3. And then you want to just do a little bit of simplifying, nothing in the first parenthesis. You get a squared b squared, then put your 3 in front of your AB, and then you square your 3, you get 9. And only one more slide left. So here, we want to go ahead and simplify this. Some of you might be tempted to cross the a squared out on top, a squared on the bottom. But consider this over here. We have 24 over 36. You know you could factor it and get 12 times 2 on the top, and you can get 12 times 3 on the bottom. 12 over 12 is a special form of 1, so this problem reduces down to just 2/3. In other words, you can cross out things that are multiplied by the top and multiplied by the bottom. You'll notice over here our a squared is not multiplied by the top and multiplied by the bottom. So you need to do your factoring. So you'd want to do AC factoring on the top, and you would eventually get this. Do your AC factoring on the bottom, and you would eventually get this. Now you'll notice that you have an a plus 2 times the whole top and an a plus 2 times the whole bottom. That's really a special form of 1, so the a plus 2's drop out, leaving you only with an a minus 3 on the top and an a plus 5 on the bottom.